And now we have our final video in our 4.3 series. Here's G, and we're doing the Fall 19 Exam 2, number 5. And the problem states that an alien is building the wireframes of two pyramids. One has a base that is an equilateral triangle with side lengths x, and the other has a base that is a square with side lengths r. The shapes are shown below. For both, all triangular faces are equilateral. Okay. The alien has 2 meters of wire available to build the frames, and we'll use all of it. Find a formula for r in terms of x. This is always a constraint problem. And so we have part A, find a formula for r in terms of x. And we're going to start out with our constraint, which was 2 meters. And if we think about what r was the sides of the square pyramid. And so we had 4 r's if we did the square. And then we had to have 1, 2, 3, 4 of them. So really, we're looking at 8 r's, yes? Similarly, for x, we have this triangular base, and my triangular base pyramid doesn't look nearly as good, but there are 6 sides there. Now, if we're looking for a formula for r in terms of x, that means this is going to be our dependent variable. That's going to be independent. We're going to solve for r, so we'll subtract 2 minus 6x divided by 8 is equal to r, and we're through. In part B, we're asked to find a formula for the combined surface area of the two pyramids, the total area of all sides and bases of both shapes. And our formula should be in terms of x only. Recall that the area of an equilateral triangle with side length L is root 3/4 L squared. So that's the area of any equilateral triangle, which is a great thing to know. So if we go back to our problem, I think we're just going to start out with any old surface area. So the surface area of this thing is going to be 4, and I have 4 sides, and keep in mind that the length was x here, so it's going to be root 3/4 x squared. On our other triangle, though, I'm still going to have the 4 triangles, 1 on each side. So 4 times root 3/4 r squared. But now we have one additional piece, and that's the square base plus r squared. Unfortunately, right now, we have a problem because I have x's and r's, but we want to have the surface area only in terms of x. So what I might do is a little bit of housework here. That's going to be r squared times 4 root 3/4. I guess I could have murdered those 2 plus 1 plus this term right there. And so that way I only have to substitute instead of r this expression one time. So the area as a formula of x is equal to root 3 x squared, and there I did murder those 4's out, plus 2 minus 6x over 8 quantity squared, and that's my substitution of my constraint into my surface area, times root 3 plus 1. Almost done, friends. Moving to part C, which is undoubtedly going to be a domain question. We are told that the alien wants to actually build one of each type of pyramid. That right there is actually very telling. That means that r has to be strictly bigger than 0 and x has to be strictly bigger than 0. If either of them is 0, then we're not going to be able to make our pyramids. In the context of the problem, what's the domain of the function? So we know that we are certainly looking for these are x values, yes? We're looking for x's. We have an x inside of our area function, but we're still not looking at the area function. This domain idea comes from the constraint. So, what happens to this? Certainly, x cannot be equal to 0 because I need to have one of each type of pyramid. So, can x get super duper close to 0? And the answer is yes. This means that 0 less than x is our low end. Now, on the other side, can r be equal to 0? And the answer is no, r cannot be equal to 0 because, once again, I need to have one of each type of pyramid. And so now what happens as r tends to 0? And let's go back to our original constraint equation. 2 is equal to 8r plus 6x. Well, as r tends to 0, that whole term is going to tend to 0. So what's x going to tend to? Can you see it? Well, essentially solve for x, and x is going to tend to 1/3. Yeah? Now, x will never equal 1/3. X will get closer and closer and closer to 1/3. And we're done with our domain. We should probably take a quick pause to see that we are in meters here, and we're through with our problem. If you have any additional questions or concerns, please make sure to post on our message board or email me directly.